This conference will now be recorded.
Once again, thank you. Good morning. If there are any questions around the course content, feel free to put it in the chat, or you can feel free to ask the question, guys, in the first 2 to 3 minutes. Today, what we'll do is I'll just pick randomly a topic from our course content, just for you to understand the way these sessions are going to get handled, the way you will learn, just to for you to get that confidence or get that understanding. I'll just pick a random topic from this list, and then I'll go over the next 30-40 minutes. That is the plan for today, and from tomorrow we will get started with the from the first as per the schedule. Okay, with the Java basics and JVM basics we'll go over. Okay, today the plan is to I'll pick Java threads as one of the topic, and then we'll go over to understand what is Java threads, how it is created, destroyed, what are the various states of thread. So all these things we will look into it in detail. Okay, I'll just take a pause for a minute. Just wanted to know if you have any questions around the topics or the contents, or any other question, guys. Okay. Anyway, there are no questions. I'll get started. Okay. Okay. So the I was mentioning yesterday, right? The threads are your task handler. Okay. You have your CPU, you have your RAM, and for any application to work, say for example, you're going to do a login, or you're going to do a search or any operation. It comes to the server, and server needs CPU power to process that code, or to execute that code, to execute that class file, or execute that application. It needs a CPU power, right? And it also needs the RAM or heap to store the variables temporarily when these executions are going to happen. Within the login, whatever variables are getting declared, to store those variables temporarily in the heap, you would need the memory. It is always CPU or memories are going to be one of the important from a capacity perspective, and threads are going to be the one which is going to handle your task. Okay, and every thread in turn will need a CPU for execution. That is how it works. So a thread, you can just think as a your task handler. Okay, that's a handler which will receive the task, and then which will execute the particular piece of APIs or code, and then once the task is over, it will pick another task. So it is just a task handler. Okay. I'll always compare this with your kind of Swiggy delivery, right? You have, if you have you might have all have used Swiggy at some point of time. The way they work is, there are going to be some 8-10 people, a delivery person who will be waiting in the somewhere in the near to the restaurant, right, in the parking lots, waiting for the orders. And if somebody is going to order a food, the request will be assigned to a person who is idle, right? Whoever is not having any delivery already assigned, you will get assigned with that food delivery, and then you will wait for the food to be prepared in the restaurant. Once it is ready, he will deliver it back to the whoever is requested. Okay, and that's how the round robin way the request will be assigned, and food will be delivered. Okay, and normally what happens is in the daytime there might be a period where you will have a lot of requests, right? In the morning or maybe in the late in the evening, you will have a lot of people ordering the food. Maybe in the afternoon or evening, you will not see that kind of traffic or that kind of demand, right? So the way they will the Swiggy will deploy is they will deploy say 10 or 15 people to handle the peak hours in the morning or late in the evening, and in the afternoon they will just deploy or employ only 3 or 4 people, just to meet this um, uh, uh, peak and off period within a daytime. Okay, so this continues every hour, every day, every week, right? That's how it continues. Similarly, when you look into the way thread is going to be used or handled by any server, when a server starts, when your Tomcat starts, okay, when your JVM starts, your thread will also get started. Okay, and when a request comes, uh, uh, say there are 10 threads. When a one request comes, a thread will get assigned with the task. Okay, and if there are multiple requests coming in, say there are 10 logins coming in, 5 logins coming in, these threads are going to get assigned with multiple requests parallelly. Whichever is idle, that request that thread will get assigned with the new task. If all the threads are busy, the task has to wait, right? And similar to the way Swiggy handles the off period and peak period, here as well you have that flexibility where you can say I need 20 as a minimum and 50 as the maximum, which means at the beginning, when the Tomcat starts, it will give you 20 threads by default, and it will keep handling all the requests. At some point of time, if the requests are coming more and 20 threads are couldn't able to handle it, automatically 21, 22, 23, 25, 30, 35, 40, 45, 50 will be will start will get initiated, or the extra threads will get initiated to handle the additional load. And after some point of time, if the traffic is less, there's very less amount of traffic coming in, automatically the additional threads will come down to 20. But any point of time, it won't go below 20. So it will be between min and max. Okay. So just for your understanding, I have compared with the way Swiggy operates, just for you to remember these concepts. But yeah, the threads are going to get created. The whatever minimum you ever mentioned, it is going to get created at the start, and it will be there forever till you kill the JVM. And additional threads are going to get initiated as the requirement of requests are going to increase. The demand is going to increase. The threads are going to get new threads are going to get initiated, and it might get killed in between as well if the demand goes down. Okay, so what we will do is, these are the various states of the thread. Okay, within a server, the thread can go into these states: new, runnable, running, waiting, terminated. So when a thread is getting started, or thread is getting initiated, it got created, it is going to be in a new state. Okay, and then it will go into immediately it will go into a runnable state. Runnable state is kind of it is free, or it is, you can say, it is in a parking state where it is ready to pick the work. It is idle, it is ready to pick the work. There is no request assigned. It is ready to just pick the work. From there, once the request is assigned, it can go to running state. It is actively doing some work, and in between it can also go to some state called waiting. Okay, so waiting can be many ways. It can be forcefully waiting because of thread.sleep. If a developer has kept a thread.sleep in a code, the that will sleep for that moment, 3 seconds, 2 seconds, 1 second. Or if there is a condition where a thread is getting blocked, we'll look into the blocked state, monitor state, and all in detail later. Blocked is another thread is blocking the another thread. Okay, one other thread is blocking the another thread. So this blocking state, It's something a problem, something a bottleneck from a performance perspective. We need to avoid those blocked state. For that reason only, we'll go and take a thread dump and then see what all threads are there in blocked state and why it is in blocked state. We'll be looking into it in detail about the thread dump and all later. So states of thread is new runnable. Um, Runnable is nothing but idle or parking state. From there, it can go to running state. From there, it can go to waiting state, and finally, it can also get terminated. What I'll do is I'll just go start my Tomcat, which I think yeah. Let me go and start the Tomcat. I'll kill it first. I'll go and deploy this. I'll copy the WAR file always. I'll be uploading the WAR file. The way you have to follow that is you go to your web apps. Okay, there's another video that I'll ask the Isha to add into your the YouTube playlist, where I would have explained how to install Tomcat, how to deploy the WAR file in detail. The same thing whatever I'm doing it, right? I'll go to the web apps. The WAR files will be available in the Google Drive. You download the WAR file for each category. When you go to look at the response time issue, or whenever you go to look at the thread issue or a memory issue, in respective folder you will have the WAR file. Okay, and then take the backup. I'll delete this. You just need to go and copy this, nothing else. Just copy the WAR file. Maybe I might have given it with the different names while uploading it to for us to understand what WAR file it belongs to. I might have given e library underscore response time issue, memory issue. When you copy to the web apps folder, you rename it always to e library. That is how you have to rename it. Otherwise, the application will not start. Okay, so this e library.war has to be there in the web apps folder, and then what I will do is I'll go to the configuration file and open the server.xml. Okay, this server.xml. Okay, if you look at the server.xml from the top to bottom, there will be a section where I would have mentioned the port in which this JVM will run or a Tomcat will run, and then I would have given the minimum thread and maximum thread. See, for example, I'll just go and modify the minimum threads to say 3, and then maximum thread to say 5 or 6. Okay, I saved it, and then now I'll go and start the thread. What is the minimum criteria? What is the maximum criteria? That all will come into while we do a benchmarking, right? The multiple things required for JVM benchmarking. We need to know what are the min thread, max thread, minimum heap, maximum heap. All these things we will be, say for example, if I go to the catalina.bat file, that is where I will go and specify what is my heap requirement. Okay, what is my minimum heap that is required, what is the maximum heap that is required here. Okay, so what is the minimum heap we should give it, what is the maximum heap we should give it, what is the minimum thread we will give it. All these things is part of your JVM benchmarking. While we do that JVM benchmarking exercise, we will learn how to arrive at these numbers. Okay, for now, I'll just given some random 250 MB to 750 MB of heap, and 3 minimum threads and 6 maximum threads. Okay, I'll start the server. Okay, and in parallel, I'll also open a couple of tools. Okay, I'll use JVisual VM. Okay, and JVisual VM also is uploaded to your drive. Okay, you just need to download and then open your JVisual VM. You need to double click it. Okay, either you double click it, okay, or sometimes it will say Java not found for Visual VM. Okay, so in that case, you have to um, explicitly mention like this: Visual VM.exe followed by where is your Java, where is your JDK. Tomorrow, while we start with the Java basics, right, I'll be telling you what is JDK, what is JRE, how to configure the environmental variables for Java. All these things we'll be looking into tomorrow. Because for any Java app to work, you need to specify where is Java installed. Okay, so while opening the Visual VM, so you go to this folder wherever the Visual VM is copied, downloaded, and from there you just provide the that exe name and then followed by JDK home. My Java is copied in or installed in program files Java JDK. So just give that the path. Okay, so Visual VM will get opened. Yeah, Visual VM will get opened. Okay, and once it is opened, my Tomcat is also running. You can go and select the Tomcat and go to the threads. And in the threads, if you come down, there will be HTTP executor. This is what you need to look into. HTTP, our port is 8083, executor 1, executor 2, executor 3. So it will be prefixed by exec, executor. If you see here, there are only 3 threads. Okay, executor 1, 2, 3, only 3 threads because we have given minimum as 3. Okay, and then if you look at the color, right, if you see to the bottom, it says running, it's green, the gray is sleeping, yellow is wait, park, and monitor. Okay, now currently if you see everything in the parking state, if it is running, it will go into green. If it is sleeping, it will go into the gray. And monitor is something I was talking. Monitor is nothing but a blocked state. If a thread is blocked by another thread, the thread which is getting blocked will go into this light green. Okay, this is more from our understanding of the thread state. While doing a load testing or endurance testing, we will not use this view to monitor the threads because it is you go to have 150 200 threads running in concurrently. So monitoring a thread state using this view is not going to be easy at all, and you will not be able to infer that easily. Okay, we will be looking into a different way of the thread state in a different way. I'll tell you later, but this is for you to understand the concepts, understand the your thread state. I'm opening the Visual VM and going into the threads and then showing you this view. Okay, now what I will do is I'll just go and launch the application. Okay, I just go and launch the application localhost 8083. Once I type enter, okay, one of your thread, okay, if you see here, executed 2 has picked some work. Okay, and executed 2 from green, it goes to gray. Okay, and then again it goes to parking state. Okay, so now if I'm going to execute this, maybe I'll open the Jmeter. Jmeter, I have a simple script which will just launch the library page and do the login, right? I'll just execute it with a say one user continuously, right? Okay, now if you look into the thread state, okay, executor 3 has picked the first request, and then for the second it is going to a sleep state and then into a parking state. Again, when the second iteration of login happens, the task is assigned to the thread 1. Okay, now again the third iteration would have started. It might get assigned to the third now. So round robin, it might go between these three threads. Since there's only one users that is executing this script, at any point in time, you will have only one active threads. Okay, now I'll go and stop it. Okay, I'll just give 2 users. Okay, and then go back here. Now you will see that at least 2 threads will pick the work. 1 and 3 has picked the work now. And for the second request, it will again go and get assigned to the other threads. Yeah, now 1 and 2. So still, if you see there's only 1, 2, 3. Only 3 threads are available because minimum must be given 3. Now, if I go and so threads are not busy because there are only 2 users. There are 3 threads. Now, if I go and probably give a 5 users. Okay. Now there are 5 consecutive users going to execute this flow. Now I give start. Then if I go there, you will see that some point of time it will go and create a new thread. See now 4, 5. 5 threads are created. 1, 2, 3, 4, 5 threads are created because there are 5 consecutive users. Tomcat has seen that there are parallel requests coming in. It cannot handle with 3 threads and it has a cushion to go for 5, right? So why can't it can go and spin the additional 5? More than 5, it won't do it now because we have given only 5 in the configuration file. If we go here, the configuration file we're given 6. So it will go up to 6. Okay, for now it has spin only 5. It can go up to 6. So with 5, it could able to handle the load. So it is just started with the 5. If it required, it will also go and spin the 6th one. Okay, so every thread will go into the parking state, running state, sleeping state, round robin. This will continue in this fashion. Now, if I stop the test after a few seconds, let's see what happens. I'll go and stop the test. Okay, I have stopped the test. Let's see whether the threads are going to stop. At least 2 threads will get stopped. Still it is there. Still all 5 are now in a parking state. So after a few seconds, 2 out of 5 randomly it should get stopped. It might take few more seconds. Yeah, if you see now 1, 3 and 4, 2 and 5 got killed. Okay, so it will go back to the min, right? Max is 5, min is 2. So after some seconds, it has seen that all the threads are idle. There's no requirement to have the additional threads. So it is automatically killed it. The reason for killing is even though the threads are not going to be in a running state, once it's initiated, right, there is some level of CPU it will consume. Okay, though it is in idle state. So that is the reason always Tomcat will try to go and kill the um, uh, threads which are not required, right? But it will go and kill till only the minimum. It won't go beyond that. So any point of time, it will maintain the minimum threads, but it can go up to the maximum based on the demand. Okay, so this is how the threads are going to get initiated and then it will go into a new state. It will go into the uh, parking state. It will go into the sleeping state, and then back to the it will also get terminated if the demand is not there. Okay, what I'll do is I'll go and deploy another war file to just to see that monitor state.
Shruti, this is Zahid. I have a question.
Yeah, go ahead.
So the 5 concurrent users that you provided, that is within the limit, like because the config file has 6, right? The max. Now, what if you
Uh-huh.
do 10? What if you do 10 concurrent users? Would it block, or would it go into wait state? What
It will
actually
go into
happened?
the state. Your response time will increase. So all the 5 or 6 will be busy. So the other request will wait. Okay, and which means your response time will for example, if I go and check my response time now. Okay, my response times are probably login response times are around 4 seconds. Okay, 4052, 4099, 4076. So it is kind of a in the 4 seconds. Okay, what I'll do is I'll just clear this. Okay, let it run, and then let's just give me 1 second. Just give me 1 second. I'll just clear this out. The answer is the response time will increase for sure because it has to wait, right? Uh,
Makes sense. Thank you. Yeah, I understand. So there'll be a wait time for the whoever comes next.
Correct. And if the users are more than 10, 15, um, right? That is where you will getting the timeout. If it is going in the Tom code, there will be default timeout. If a request is waiting for more than 10 seconds or 60 seconds or 30 seconds, then you will get a timeout in your browser. Okay, it will be too busy, so you will get a timeout. So yeah, that is how that is the impact of. If I go back to the slide, right, I might have mentioned about this. So there are two kind of problems you might see. One is you might have two less threads. That is where you get a thread related problem. Normally, what happens is you do a load testing, um, and then say you do a load testing with 1,000 users. And initially, your server team might have configured say 300 threads or 400 threads to handle the 1,000 concurrent users, and everything would have been all good. But second, when you go for a scalability or stress test, right, with 2,000 users, they might not have changed that thread min max value. So which means during the stress or scalability, your response time will definitely will shoot up. Okay, and if you go and look into the thread utilization, it will be 80% or 90%, which means either you have to increase the thread again, but it's not straightforward. You cannot go and just increase the thread, right? Because thread and CPU are interrelated. I'll go over these in detail during a JVM benchmarking. The way we do the scalability, we have to start with some number for thread and heap. You have to increase it. You have to increase the concurrent users, see how it reacts. What is the CPU utilization? What's the thread utilization? Multiple things you need to monitor before you decide that okay, this is the capacity of your JVM. So normally when you increase the load, if the threads are not increased cautiously, you will see a response time impact, or you might also see your server is busy, server is not responding. All these kind of errors you will see it in the browser. Okay, so
Thank you.
yeah. Two main problem is one is this thread utilization or thread is not enough, and second is something called thread locks. or a synchronization problem, right? When a particular thread is going to get blocked, then what happens is a thread has to wait, right? So the impact of this is say login, which should have been completed within 3 seconds. Now, because it is a blog, it might get finished in 8 seconds or 7 seconds. So one, the impact is response time. Second, unwantedly, see, there are only 100 threads, for example. One thread is now blocked for 8 seconds. Similarly, the various threads are getting blocked at, say, at some point of time for 5 seconds, 7 seconds, 8 seconds. So the capacity of your threads are going to come down. Instead of handling 30 concurrent users or 100 concurrent users, because one login itself going to take 8 seconds, your capacity will come down. Okay, so unwantedly, you might need to have more threads, or CPU will increase. There are more impact because of the your thread blocks. We'll again look into in detail about these thread blocks, how to take the thread dump, how to identify thread blocks, what is, how to find the root cause. All these things we'll be looking into in detail. I'll just go and deploy a war file which will have this thread problem. Okay, so that we'll be able to see the similar way in JVisual VM. We will see how the thread goes between running state to your blocked state. I'll just go and take a I already added in my I just renamed it. Okay, I'll delete this war file. The first thing is I'll go and stop this. I'll go and stop this. It is already stopped. Okay. Okay. Now I'll go and start the. Okay, it is started. I'll just go and two. I need to close this. Okay, I'll open the Tomcat and go to the threads. Come down. Yeah, there are 3 threads. Okay, now I'll go and start the Jmeter test with just 2 users. Okay. Okay. Now, if you watch, okay, you see now the executed 2, it is in a blocked state. Okay, you say something called monitor, right? The light green is monitor. Now the executed 2 is in a blocked state. Now executed 3 in blocked state for just for a moment, right? Why it doesn't block the state, that is all different reason. We'll try to learn the synchronization uh, functionality, how it will impact the threads to get go into a blocked state. Those things we'll look into it detail while we go into the sessions. But yeah, just for your understanding, the different thread states are running, sleeping, parking, and monitoring. Okay, and if you wanted to group into a proper way, and every tool might represent in a different terminology, but ideally the states are, it will be, if there's no request, it will go into a parking state or in a runnable state. It is ready to run, it is in a parking state or idle state. Okay, parking, idle, everything is same. While it is running, it is in a running state, actively doing some work. In between, it can go to the sleeping, it can go to the monitor state also if the thread is blocked. And when it goes to monitor state, and if it is going to stay for a second or two, your thread utilization will increase, your CPU utilization will increase, your response time will increase, and some amount of time your JVM will come to a kind of a crashing mode, right? So there are patterns in CPU thread, we have to look into it. Based on that, we will go and do a thread dump, and then we'll analyze the thread dump to get the root cause. Okay, but I'll not go into in detail about those root cause or dumps late today. But yeah, I'll just stop it here. I just wanted to yeah, introduce you to this thread and thread concepts and visually see you, so show you how it getting represented in a JVisual VM. Okay, I'll take a pause here, guys. So I don't want to go into detail because I wanted to still explain you about the basics of Java, class, object, method, um, your JVM, setting up this environmental variables, all these things from tomorrow. So we'll start slowly from tomorrow, from a basics, and then go into these various sessions. Okay, I'll stop here. If you guys have any questions, yeah, please let me know.
Hi, Satish.
Yeah, go ahead.
Hello. Yeah, hi, Satish. Lalit here. Very good morning.
Good morning.
Is there any UI tool? We are using Linux actually in our production environment. And do you have any tool? You have shown some visual tools. That any visual tools is done in Linux system?
See, this is a Java. Whatever I showed you, see JVisual VM or JConsole, all these are all Java utilities. Okay, so you can use the one I'm sharing, JVisual VM, JConsole, right? This as well you can use it.
Okay.
JConsole also from your laptop. See, what you will do is, in the Linux machine, your app server will be running. Right, my Tomcat is now running in a this machine, Windows. In your case, it will be running in a Linux. Right?
Linux
So
server, exactly.
yeah, what will happen is, from your laptop or from a Windows VM, you will connect to the Linux machine, and you will open the JConsole. You will open the there's something called connection, and then say a new connection. Instead of local process, it will be a remote process. And there you will give the Linux machine IP and port, and then connect to the your Linux
Okay,
machine.
I got it. Thank you. I have second question. What you mentioned that the threads are defined in the server.xml file of the Tomcat. Sometimes I have seen in the application they are defined also in properties. They are thread text, batch size, it is configured in properties. I just want to know whether which is more priority. It is the application level is given more priority or Tomcat level is given more priority.
See, it depends multiple ways you can override it. Okay, but the one which are give it in the server level, okay, that will take the precedence. Your application getting deployed, and so within the application property file, you might have mentioned about these threads. Okay, and in the Tomcat as well, the JBoss as well, you can mention these attributes. But the one that you're going to mention at the top level, at the server, your web server level.
Yeah, got it. Thank you. Okay.
Yeah. You just need to follow the way. See, there might be a different way each team follows to configure the heap or threads, right? It is just more about you know, maybe they might be having a specific way of doing it. You just need to find it out. But more from engineering, you need to know why we need to do it and what is the value we need to keep it. Where to do the changes? It keeps changing, right? A lot of servers, lot of different ways. So we don't need to worry about where to change it. It's just a matter of you going and checking with your deployment team or server team what they do, and we will follow it. But why we should change it, what it has to be changed, that is where the engineering will come into picture.
Yes, sure. Thank you.
Sure. Okay. Any other question, guys? Any other question about the course content or the timing will be the same time as I mentioned earlier. It will be from morning 7 a.m. to 8 a.m. And if you have any questions on the registration, you can reach out to Kumar sir. Okay. And if you still have any questions about the course content, or if you want to discuss with me about the relevancy of this course for you, with your experience and all, just message me. We can connect offline as well today. Okay, the actual session will get started from tomorrow. So yeah, okay. Thank you guys. Thanks for your time. We'll meet tomorrow then.
Okay. Okay. Thank you.
Yeah, thank you. Thanks everyone.